Good morning, dear students. So, as we have already started geometric progression, okay, and in the previous lecture, I have explained you. Uh, we discussed the definition of geometric progression, and we have seen the formula for the general term of geometric progression. Okay, its definition says a sequence of a non-zero number is said to be geometric progression if and only if the ratio of any term to its preceding term is constant. Okay, so if you have a non-zero series, say for example ar square, ar cube, and so on up to ar to the power n minus 1, then this is called a geometric progression where the ratio of the number to its preceding term, that means ar upon ar, ar square upon ar is also ar cube upon ar square is r. So as you can see, the common ratio, that means second term upon first term, third term upon second term, fourth term upon third term, the ratio is constant. Hence this such type of series or progression are said to be in geometric progression. Okay, now what is its general term? So general term, or the last term, we can say, as I wrote here, a r to the power n minus 1. How I have written a r to the power n minus 1? Because these series is of n terms. Okay, n, I've started writing r just from the next one, so one is remaining. All right, that is why I've written here a into r to the power n minus 1. So its last term, okay, what do we call last term? L is equal to a into r to the power n, or an we call. Okay, same at a time, either L or an, that is the last term. Okay, so based on this, we'll start with the question. But before that, as you can see the remarks here, that is important thing. What remarks I'm talking about? If the product of the number is given, then in a GP, three numbers to be taken are a upon r, a, and ar. I mean to say that if three terms, they are in GP and their product is given to us, so what selection we should do to get the answer in a better, that means to get the optimal answer. All right, so we used to choose a upon r, a, and ar as those three terms. So when we'll do the product, this r and r could be cancelled and we're left with one unknown variable, and we can easily find. That is why we need to select such numbers whose multiplication, or if in the question if they say addition, so that too we have to select properly. Okay, so there's some suggestions you can take from the book. Okay, the remarks which I'm talking about, you can see for the three terms what all three numbers should be taken, four numbers, five numbers, like that. Okay, now let's start with the exercise. As I told you that to do the starting questions, I hope you have done up to 9. See, up to 8 and 9 questions one can easily do. All right, let's do the 10th question. The fifth, eighth, and 11th term of a GP are P, Q, and S respectively. Show that Q square equal to PS. Let's do this. So as you can see here, A5, A8, A11, PQS to prove Q square equal to PS. We know A5. A5 according to the formula, A r to the power 5 minus 1, A r to the power 4. So P is equal to this. A8 will be A r to the power 7. So Q is equal to A r to the power 7, and A11 will be S is equal to A r to the power 10. Now LHS is what? Q square. Okay, so squaring this, we got A square r to the power 14, and RHS P into S. P is this, S is this, on multiplying A square r to the power 14. Okay, so like that we can understand. Okay, so here you have the next question, that is, if A, B, C are in GP, then show that A square, B square, and C square are also in GP. Okay, so if A, B, C are in GP, so can we write that B upon A is equal to C upon A? Can we? Sorry, B upon A will be C upon b, right? Take b that side, so it will be b square is equal to ac. Okay, we need a square, b square, c square. Here b is with square, but a and c are not there. So for that we need to square both the sides. So just square. So it will be b to the power 4 a square c square. Now break this b to the power 4 as b square into a square into c square. Now take this a square in the denominator here and 1b square here in the denominator. Now if ABC are in GP and we can write like this, so its reverse is also true. So if b square upon a square is equal to c square upon b square, this means that a square, b square and c square are also in GP. Like this we have to understand. Okay. Now the next question you have is, if ABC are in AP, okay, not GP, AP, then 3 to the power A, 3 to the power B, 3 to the power C are in GP. Okay, this we have to prove. If ABC are in AP, then we can write 2B is equal to A plus C. How I'm writing this? Because B minus, okay, B minus A is equal to C minus B. We know this thing. Alright, take minus of B here and negative A that side, so B plus B will be 2B and A that side, so that is how I have written 2B equal to A plus C. Now what we are doing to make this in GP, to prove this in GP, let us consider that it is in GP. Okay, so let us consider 3 to the power A, 3 to the power B and 3 to the power C are in GP. So if they are in GP, then can we write by the formula 3b the whole square is equal to 3 to the power A into 3 to the power C. Okay, the second one's square is equal to the multiplication of the extremes one. Okay, from here this two, if you multiply, so 3 to the power 2b is equal to by the law of indice we can write 3 to the power A plus C. On comparing the bases, we got 2b is equal to A plus C, which is true if and only if, see, we got what result we got, 2b is equal to A plus C, which can only be true if ABC are in AP. That is why from here we can say that 3 to the power A, 3 to the power B and 3 to the power C are in GP only when ABC are in AP. Are you under? Because they are interconnected. No, this three. See this ABC and this ABC. These two questions are interconnected. Okay. To make this into GP, let's prove that their powers. Okay. This ABC are in AP. So we proved ABC are in AP. Okay, by the as we considered it as in GP. So that is how they both are interconnected. So such type of proof also you have to do. Okay, let's see 14th question. If a square plus 2 and a cube plus 10, what question we have? That is a square plus 2 and a cube plus 10 are in GP, then find the value or values of A. Okay, so it's quite easy. A square plus 2 the whole square is equal to this into this. Okay, open the bracket, solve it, you'll get the answer. Okay, so here we have the next question. Three numbers are in AP and their sum is 15. If 1, 4, 19 are added to these numbers respectively, the resulting numbers are in GP. Find the numbers. Okay, so the very first case which is given to us, the three numbers are in AP and their sum is 15. So we need to select those three numbers which could be helpful for us to eliminate one variable, because we have two unknown variables, that is A and D. If we are considering A as the first term and D is the common difference for this AP. Okay, so we need to select consider A minus D, A and A plus D. Why I'm considering this? Because as they are in AP and if I add them, if I add them, 15 is given to us in the question, and this d to d can be easily cancelled, and we'll get 3a equal to 15 and a is equal to 5. So we got a as 5, right? Now put here in this whatever three numbers we have taken, we took a minus d, a and a plus d. So those three numbers will be now 5 minus d, 5 and 5 plus d. Now 1, 4 and 19 are added to these numbers respectively. So 1 has to be added with 5 minus d. So it will become, on adding, please you can write the steps, okay? It will be 6 minus d. 4 with 5 will get 9, and 19 with 5 will get 19 plus 5 will be 24 plus d. Okay, now if they are in GP, okay, then we need to find those three numbers. So if they are in GP, we know the middle terms square, that is 9 square is equal to 6 minus d and 24 plus d. Multiply these two bracket, get the answer and find those three numbers. Can you find? Okay, find it and let me know. Okay, now I'm taking one question, okay, in which you have to remember one point. Okay, so first of all, just see the question. If A, B, C are in AP as well as in GP, then find A to the power B minus C plus B to the power C minus A and C to the power A minus B. So here, what important thing I want to tell you, that if any numbers are in AP as well as GP, so you have to remember those three numbers will be always equal. This is very important point you have to remember, that whenever a sequence or any number are in AP and GP both, then all the three numbers will be identical. How? So for example, 1 1 1 I'm taking. So these three numbers, they are in AP also and they are in GP also. How? 1 minus 1 is 0, 1 minus 1 0, AP satisfied. 1 upon 1 is 1, 1 upon 1 is 1, GP also satisfied. Okay, so the numbers has to be identical for to be in AP and GP both. So A is equal to B equal to C. Now we can easily find, no? A to the power B minus, in place of C I'm writing B. B to the power, in place of A I'm writing C, and in place of B I'm writing A. So B minus B is 0, A to the power 0 plus B to the power 0 plus C to the power 0, 1 plus 1 plus 1. Answer is 3. Okay. Now the next question. If A, B, C, D are in GP, then A square plus B square, B square plus C square, C square plus D square are also in GP. We have to prove. Okay. So given that A, B, C, D are in GP, okay, so let us consider first term be A, second term is B. Okay, so can I write, I'm considering B is equal to A into R, where R is a common ratio. Okay, so A will be first term, B I'm considering A into R, because to get the second term I need to multiply with some quantity to the first term. I'll get this. For C, it will be A R to the power 3, right? And D will be A R to the power 4. Okay, now to prove that this three terms are in GP, what we have to prove, the square of the second term will be equal to the product of the extreme terms. So let us go and find B square plus C square the whole square. Okay, so B square is what? AR. C square is what? Sorry, B square is AR the whole square. C square is AR cube the whole square, and the whole square. A square R square plus A square R to the power 6 the whole square. Now from inside you can take A square R square common. Okay, you will get 1 plus R to the power 4 the whole square. Okay, now what you can do, wait, something is sorry, this is AR, you need to take AR square here in this and AR cube here. Okay, so wait, this will be now it will be a square r to the power 4, and if you take a square r square common, it will be like this. Now when this a square r square comes out from this this whole square, it will be a to the power 4 r to the power 4 1 plus r square. Okay, now multiply what, a square plus b square and c square plus d square. So a square, what we have, a square, that is a square only. B square is what, AR, so a square r square I'm directly writing. Okay, c square is a r square, so it will be a into r to the power 4, and d square is d square will be a square r to the power 6. Okay, from here what you can take common, a square, so you will be left with a square. From here you can take a square r to the power 4 common. Inside you will get 1 plus r to the power r whole square. Now a square into a square, a to the power 4 r to the power 4, 1 plus r square, 1 plus r square, 1 plus r square the whole square. Now this quantity is equal to this quantity, hence these two are equal, and if these two are equal, this means this three terms are in GP. So like this you have to do. I hope you understood. Now let's come to one practical question, word problem. The last one, if you could see in the book, I'm reading the question, please concentrate. The lengths of the sides of a triangle forms a GP. So we have a triangle, okay, and the sides, they are forming a GP. Okay, if the perimeter of the triangle is 37 centimeter, perimeter is given 37 centimeter, shortest side of its length is 9 centimeter. Okay, one information is given, find the length of the other two sides. So if I consider its sides as AR and AR square, why? Because they are in GP, so we need to consider accordingly. And the shortest side is 9 centimeter, so let that shortest side be A. So A is equal to 9 we are considering. So its second side, this is the first side, its second side will be 9r, and its third side will be 9r square. Its perimeter is 37, so add these three, a plus ar plus ar square, sorry 9, it's 9. Okay, 9r 9r square is 37. Okay, and after that take this 37 this side, so it will be 9r square plus 9r, 9 minus 37, you will get minus of 28 equal to 0. Now this is a quadratic equation, so you need to solve it for r. You'll get two values. From those two values you know what to do, put here, you will get the answer. Okay, so that is how we completed this exercise. Now let's discuss something about the next exercise, that is sum of first n terms of a GP. You know what is the sum of first n terms of GP, right? In the, I guess, 10th class we have seen the sum of, if see, as in the arithmetic progression we have that means sum of the series. In the geometric progression also we have sum of series like this. So Sn is equal to a into 1 minus r to the power n upon 1 minus r, provided if r is less than 1. If r is greater than 1, then the formula, there is a change in the formula, the orientation will be changed. 1 minus r to the power n is there, so it will be r to the power n minus 1. Okay, so I think we'll discuss this in the next lecture, no worries. Okay, so we'll start with the next lecture, but just have some knowledge. Okay, if you could do the starting questions, it would be very good. Otherwise we'll do in the next lecture, we'll start from the first only. Okay, so till that, do practice. Thank you so much, have a nice day, bye bye, thank you.